Hello, 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 everybody. Happy Friday and welcome again to math class. Yes, I'm in a suit. It's not the most comfortable thing to be wearing right now, but it was fancy day today, or is fancy day today in 5th grade, and so here I am in a suit, going the extra mile by putting on a tie. It is slowly crushing my neck, and I can't breathe. But I will persevere through this adversity just for all of you. Here is our teaching points today, improper fractions, and I subtitled it Division in Disguise, because it kind of is. Down here, those are our I cans today. I'll read them out. I can define improper fraction, and I can use division to convert an improper fraction into a mixed number. Sounds doable, and we've got the skills to do it. Here's what you'll need. Something to write on, something to write with. Okay, let's get into it. So before we really get into this idea of converting an improper fraction into a mixed number, we've got to first define what an improper fraction is. And by doing that, I've got our counting numbers up here on the board. I'll go this way so you can see them. 1, 2, 3, 4, so on until the cows come home. We could count as high as we wanted to. We're in 5th grade. We could count past 1,000,000 if we wanted to, but it would be very uninteresting, so we're not going to do that. And down here underneath our counting numbers, I just put little, ones counters just to kind of show a visual, because it often helps when we're talking about fractions if we have that visual. If we were going to count by ones, but we were going to use fractions to do it, what would that look like? So let's take halves first. Okay, so let's cut this 1 in half. And we haven't added or subtracted anything, so we're going to keep that 1 and color in both of those halves. So now we have 2 halves. I'm going to write it down here below it. 2 halves. If that were to continue, how would we represent 2 if we cut each one of them in half and didn't take away any value? We'd have 2 halves plus 2 more halves, or 4 halves. Let's do it again. 2 halves plus 2 halves plus 2 halves, 2, 4, and 6 halves. 2, 4, 6, 8 halves. And so on. What would the next one be then? 2, 4, 6, 8, 10 halves is equivalent to 5, right? 2, 4, 6, 8, 10. Two halves in each piece. And I wanted to point out something about this. We're not changing the size of our piece. We're working in halves this whole time, so our denominator is not changing. And our numerator is going up by 2. And would that hold true for every denominator? So if I had this instead of halves, maybe I was in thirds. How many thirds are our equivalent of 1? That's right, 3 thirds. Okay? 3 thirds plus 3 more thirds would get you what? Denominator stays the same when we're adding, because we're not changing the size of the piece. 3 plus 3 is 6. Let's use the wider end of the marker there. 3 plus 3 is 6. And then so on to 3 plus 3 plus 3 is 9. 3 plus 3 plus 3 plus 3 is 12. Add another 3 to that, you get 15, and so on until the cows come home. I'm starting to slant upwards here. Now, this is important to note because I want us to make a connection. Let's take a look here at 10 halves equals 5, right? Ten halves equals 5. Have we seen these three numbers sort of be connected before? Well, I definitely know that 2 times 5 is 10. And 10 divided by 2 is 5. Does that hold true for every fraction? It does. The number of pieces, and then how many pieces are in each group, it's the same thing as division. Okay? 10 halves equals 5 is essentially saying the same thing as 10 divided by 2 equals 5. Okay, and you can even look, there's this sneaky division sign. Why does it look like this? Maybe because there's a line here and a line here. There's a dot above and below, just like there's a number above and below. What? Oh my gosh. The fractions have been hiding here this entire time. Incredible. Now, this is important when we talk about improper fractions. So when we talk about an improper fraction is a fraction greater than 1 that's not represented by a mixed number. Anytime you have something, a fraction larger than 1, so 10 halves is a great example. All of these, 4 halves, 6 halves, 8 halves, 10 halves, 6 thirds, 9 thirds, 12 thirds, 15 thirds. Anytime your numerator is a greater value number than your denominator, meaning you have more pieces than fit in one, that's what we call an improper fraction. We call it improper because it's much clearer if we represent it as a mixed number, as a whole number, plus whatever fraction is left over. Just like with division, we represent it as our quotient plus our remainder. Starting to make sense a little bit? So 15 thirds is essentially the same thing as 15 divided by 3. Okay, and we could even show that, right? We have 15 things. Can you see down here? Yes, you can. Okay, we have 15 dots. We're going to divide them into groups of 3. And we have 5 groups. Doesn't that look very similar to taking 5 things, 5 pies, and dividing it into 3 equal pieces, and ending up with 15 pieces total? Right? Pretty amazing. Okay? So this idea that fractions is essentially division, the same thing. We're making equal groups, right? Just like here, you've got 3 in each group, you've got 3 in each group. You've got 5 groups, 5 groups, right? 15 divided by 3 equals 5, or 15 thirds equals 5. So this can help us when we have an improper fraction and we want to convert it to a mixed number, because we can essentially just do division. I'm going to scoot my board over a little bit so I've got a little bit more room. And we can have some practice problems here. Oh, here. Let's hide the clutter. There we go. Yesterday's science lesson poking out from behind. If you don't know what this is from, go watch yesterday's science lesson. It was a good one. I thought I did really well on it. Now, let's take any improper fraction. Okay? This can be any fraction where the numerator is greater than the denominator, meaning there's more pieces than fit in just one group. So we could take something like 11 thirds. And we want to know what that looks like as a mixed number. So in essence, we're doing 11 divided by 3. Okay? Have you ever let's say you're, I mean, I know I did this when I was a kid, was when I was homesick, right? I'd have my 7-Up, I have my saltine crackers or my goldfish crackers, curl up on the couch, the blanket, and my PJs, and I would turn on at 10 a.m., I would turn on The Price is Right, one of the great game shows of our time. And one of the special rules about The Price is Right is they open up and there's like a product of some type, and contestants have to make a guess on how much that product costs, but they can't go over. If they guess too high, it's just like not guessing at all. They get it completely wrong. Division is similar. We want to know how many groups can we make without going over the amount of stuff that we have. So if we have 11 divided by 3, we want to know how many groups of 3 can we make until we run out of stuff to make full groups of 3. Okay, so you can draw this out. You could do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So here's our 11 things, and we're going to see how many groups of 3 we can make. Here's one group of 3. Here's a second group of 3. Here's a third group of 3. Oh, and we don't have enough for another group of 3. We've got 2 left. So we've got our answer, our quotient becomes how many groups? 1, 2, 3. And then in division terms, we'd say remainder 2. In fraction terms, we keep the denominator that we have because we're considering each of these pieces to be 1/3. So our fraction or our remainder is going to stay in thirds. And how many thirds do we have left? We have 2. So we have 3 groups and 2 thirds. Okay? Another way you can do it, don't be afraid of your fingers. Count by 3s. This can get tricky when fractions get really big, but in the real world, you're not going to see necessarily something like 384 fourths. Right? In that case, you can just use standard algorithm for division and you'll be fine. So in this case, fingers work great. Count up. If you go too many, go back. Count by 3s. 3, 6, 9, 12. Oh, that's too many. I'm going to put that one back down. I have 3 groups. Okay? And then thinking about, okay, I got to 3, 6, 9. What's 11 minus 9? That's going to tell me my remainder. So I had 11 thirds. I put 9 of those thirds into groups, into 3 groups, 3 ones. And then I have 2 thirds left over because 9 plus 2 is 11, or 11 minus 9 is 2. Let's try one more before we move to the digital whiteboard. Where is my, see if I can reach, is the microphone long enough? It is. Hey, got my eraser. All right, let's try one more. Let's go slightly bigger. Let's go 28 sixths. 28 sixths equals what? Again, we can think about it as 28 divided by 6. Or we have 28 things, we're putting them into groups of 6. We're putting them into groups of 6 because how many sixths equals 1? 6 sixths equals 1. So we're putting them into groups of 6. Let's use our fingers for this. 3, 6, no, wait, nah. I gotta count by 6s. Of course. 6, 12, 18, 24. The next one would be 30, and that's too much, so I'm not going to go there. I'm going to stay there with 4 groups of 6. Okay? Now I need to know, how many sixths do I have left? What's my remainder? I can count on. I can start at 24 and go 25, 26, 27, 28. And I know I have 4 sixths left. The other thing you can do, draw it out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. And I'm going to make groups of 6 because, again, 6 sixths equals 1. And we're trying to see how many whole ones we can make. So here's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And lo and behold, I have 1, 2, 3, 4 groups. And 1, 2, 3, 4 sixths remaining. So multiple ways to show how we're taking an improper fraction, meaning we've got a whole bunch of sixths that we could make into whole numbers, to whole ones. And we've got to divide it up in order to figure out what that mixed number is. Let's go to our digital whiteboard and try a few more. Let's start with 21 fifths. Okay, give yourself a minute and think about what strategy are you going to use to solve it. Often when there's struggles, it's because we're like, I'm trying to use every strategy at once. When in fact, just pick the strategy that works well for you. Does it work well to draw out 21 dots and then put them into groups of 5? Does it work well for you to count on your fingers until you get close to 21 without going over? Does it work for you to use your multiplication facts and going, okay, 5 times 3, that's 15. Can I go one more? 5 times 4, that's 20. Oh, that's really close. And I only have 1 left over. Okay, so remembering here, 5 fifths equals 1. So we're thinking about 5 fifths, 10 fifths equals 2, 15 fifths equals 3, 20 fifths equals 4. And then I know I have 1 fifth left over. Okay, if we were to draw that out, here's our 21. Let's put them into groups of 5. There's one group of 5, or 5 fifths. Here's 1, 2, 3, 4, 5. Here's another group of 5 fifths. Here's another group of 5 fifths, a third group. And here's a fourth group of 5 fifths with this 1 fifth remaining. So we have 4 groups of 5 fifths, or 4 ones, plus 1 fifth remaining. Let's try another one, and I'm going to give you a minute to try this one on your own. 17 sixths. What do we need to do here to figure out how many full groups of sixths can we make? Think of it like 17 divided by 6, if that makes more sense to you. And then we're putting our remainder over the denominator that we started with. So we're keeping everything in sixths. If we were to put this on a number line, right, going from 0, making a jump of 6 sixths, making another jump of 6 sixths, going to 12 sixths, and then thinking about, can I make another jump? That would give me 18 sixths. I don't have enough sixths. So then, thinking about how many jumps did I make? I made 2 jumps on my number line. Give me the purple pen here. There we go. And then how many sixths do I have left over? If I put 12 of them into our two whole numbers, how many do I have left over? What's 17 minus 12? 17 sixths minus 12 sixths. We can count backwards if we want. 17, 16, 15, 14, 13, 12. So we have 5 sixths remaining. Starting to make a little more sense. All right, try this one on for size. How about 32 ninths? Oh, now we're making groups of 9 ninths. Count by 9. Don't be afraid of your fingers. Even in 5th grade, even as adults. Like, why are we afraid of using our fingers? They're the most readily available mathematical tool we have. Use them. It's not a little kid thing to use your fingers. It's a smart mathematician thing to use your fingers. 9. 9 times 2 is 18. 9 times 3 is 27. 9 times 4 is 36. That's too many, so I'm going to put that finger back down. So we know we've got 3 groups of 9. And then how many do we have left over? 9 times 3 was 27, so what's 32? Or to be specific, 32 ninths minus 27 ninths, right? Because 32 ninths is what we're starting with. 27 ninths is equal to 3. So we need to know how many ninths have we not divided up. How many ninths do we have left over? 32 minus 27 equals 5. And keeping our denominator the same, 5 ninths. So we end up with 3 and 5 ninths. Last one, I'll send you out on it. I'm not even going to do this one. I want you, oh, where did my denominator go? Oh my goodness. I'm going to do 36 sevenths. Try that one on for size. 36 sevenths. And I would love to see the answer in the chat if you're there. Otherwise, do it on your paper or your whiteboard. If you're feeling comfortable with dividing to find improper fraction, or to turn improper fractions into mixed numbers, go ahead and try the exit ticket. If you would like a little bit more practice or a little bit more clarification, the Zoom room will be open starting at 11 o'clock. That's in about 5 minutes from when I'm saying these words live. All right, everybody, try 36 sevenths, then go do the exit ticket. I will go back to the big camera to sign off. It has been a wonderful week of mathematics. Next week, we're going to continue looking at improper fractions, looking at equivalent fractions, and eventually building up to being able to add and subtract fractions even if they don't have the same denominator. Big challenge, but we're up to it. And I do want to shout out the folks that have been coming regularly to small group have been seeing the most growth in their fractions knowledge. Weird. Turns out if you advocate for yourself and get help and you put in that practice, you are more than capable. All right. Really proud of the work that everybody has been doing this week. No secret words today. And we will see you back here on YouTube at 12:30 for our next writing lesson, where we're going to be talking about first times, last times, and turning points. Thanks for tuning in, everybody, and we will see you later.